So, start.
Yes.
So, good morning. You can see the awesome presentation here. I think they have put so much effort here to make this, right? So, I'd like to congratulate them for presenting such a beautiful model here. So, okay, come on, now start your presentation. Explain it. Introduce yourself first, and then go on.
Good morning, everyone. So, first of all, I would like to thank Sir Amit for giving us such a wonderful opportunity to present this model. So, our group name is Deuterium. I am Jagrit Korwa.
And I'm Divyanshu Bhuya.
And we have together presented a rheostat, a working model of a rheostat. So, first, let us see what is a rheostat. A rheostat is a variable resistor that is used to control the flow of electric current in a circuit. Rheostats are commonly used in many applications such as dimmer switches, speed controls, and many other appliances. So first, I'd like to call Divyanshu to explain the copper rheostat.
So here is a copper rheostat, and we have used insulated copper wire to coil around the pipe here, cylindrical shape here. So now, as you can see, while coiling it, we have increased its length to an extent, and this resistive element can be tested at any point using this pin, and we have created some spots so that the insulated cover is removed and current can be passed through it. So now I'll request Jagrit to explain the nichrome rheostat.
So the nichrome rheostat is almost the same as the copper rheostat, but the difference is that there is no insulated coating on this nichrome wire. And we know that the resistivity of nichrome is greater than copper. So nichrome is a very high resistance wire, and so most commonly nichrome is used in professional rheostats. So now the Divyanshu will present the copper rheostat.
So we have connected the wire to the copper rheostat, and now when I turn on the switch, if I put it here, the distance between the length will be shorter, so the resistance, since resistance is directly proportional to the length, the resistance will be much less and the current will flow much.
So, less resistance, more current will flow.
Yes,
and more flowing.
Yes. And as we go down, let me put it here. The bulbs seem to be going a little bit dim, but not much, because copper resistivity is less than nichromes. So as you can see, there is a very little variance to the resistance and to the brightness of the light. Now I request Jagrit to explain and show the practical of nichrome.
Okay, so the resistivity of nichrome is 110 into 10 to the power minus 8 ohm meter, which is much higher than copper's, which is 1.69 into 10 to the power minus 8 ohm meter. So now I would like to do the practical. So let me connect it. Now at this point, at the closer point, the distance between the live wire and the neutral wire is much less, so the bulb will glow brightly, as you can see here. But as slowly I move further from it, the bulb seems to be dimming, as you can see here. And at the far point, the bulb hardly even glows. So again, if I move towards the near point, the bulb will glow more brightly, as you can see here.
Wow, very beautiful. Left.
So as I mentioned before, nichrome is a very highly resistant metal. So much difference can be seen between the copper rheostat and the nichrome rheostat. But still, we have proved that length depends on rheostat. length is directly proportional to
Let's prove the factor that I have taught you, that resistance is directly proportional to the length. So when you go on with the length, resistance increases. Okay, very good. Very
Also,
good.
we have explained about that resistance also depends upon different types of materials. As you can see in nichrome, the light variance is very large, but in copper, since the resistivity is much low, there is barely any difference in the brilliance of light.
Another factor that we have proved is the thickness of the wire, or we can say cross-sectional area of the wire. The copper wire is of 25 gauge, which is very thin, but the nichrome wire is about 30 gauge to 32 gauge, which is a bit thicker than the copper wire. And so the we have proved that when we put the pin here, the bulb seems to glow more brighter than the copper wire when placed here.
Oh, excellent. Very nice.
There is a photo of copper rheostat and nichrome rheostat, and rheostat is also known as variable resistor, which can change the current without affecting the voltage by just varying the resistance. So here is just an example of any kind of rheostat which changes the position of, which changes the variation of resistance. Now, so these are some common applications of rheostat. You can use it for industrial automation, telecommunication, and lighting control, which is the most common use of rheostat. Let's see some advantages and disadvantages of rheostat. Variable resistance provides the ability to adjust the resistance in any electric circuit, and it's very flexible. But one disadvantage is that it dissipates heat. Since more resistance equal to more heat, maximum heat is released, and this also results in limited power handling. Means since heat is produced more, power will be less in compared to other circuits.
So we have a video of us working. So we request you to watch.
Rule and solid board now cutting. Wake up to reality. Nothing ever goes as planned.
Very good.
Destroy the
Well done. Very nice, very nice. Very good. Come on. Very nice. So, public, any question that asks? No question from public? Huh? Okay, fine. Great, great. Very nice. How long it takes to make this? 2 weeks. 2 weeks.
Like, it was because we went to find this light bulb. So we were like, this is more electric. And so our project was working for.
Did you know what is the element used to make this filament?
It's constant.
Why? Why?
Because it has high melting point and it can glow for much longer than any other.
Nowadays, LEDs are using this stuff. What is the? It is also called a fluorescent power. Fluorescent power. So, what is the advantage of using this type of bulb, fluorescent bulb, and this LED bulb? Advantage. Why? Earlier we have this double bulb. This is the lamp. Then comes CFP. Then comes LED bulb.
Because yes, done on how much word you got after that. These bulbs they require much
More bulb. Okay. So, why copper is considered as the best? Why not silver in India?
So since copper is more cheaper than silver, so it is widely used in comparison.
And this why does it? What is the purpose of this insulation?
It prevents, since trying to safely moving the thin short one and avoiding resistances, putting insulation there helps the current to increase the length so that the current doesn't get shorted and short circuits.
Oh, very good. Very good. Very good.